Chapter 5. So Chapter 5 is solving systems of linear inequalities. And sometimes I pair it with Chapter 3. I couldn't decide 1 or 3, and so I decided to pair it with 1 because I thought it would be too long if I paired it with 3. So 1 is a very simple chapter. Alright, so solving linear systems with 2 variables. And that's it. We're not going to do more than 2 variables. We're not going to do just 2 variable cases, no 3 variable cases. So remember, a line from Chapter 3, talked about this. A line in standard form is a number, an x plus a number equals a constant. When you graph that line, there's infinitely many solutions, right? Every point on that line, both fractions and non-fractions, are solutions. And we draw it as a line because there are infinitely many of them. Alright, so all of the points in x and y, where you plug it in, you take x times a, add to it b times y, it's always going to come out equal to c. Right? And that's infinitely many cases. Linear inequalities add a step to this. Inequality is the less than equal to, greater than or equal to, less than or greater than symbols. And we're going to always do the equal to cases because it just simplifies things to do it. If you remember from algebra, that's something you should have done in an algebra class. They did both cases. We're always going to do the equal to cases. Everything that we're going to talk about can be said with the not equal to. The only difference is the boundary are not included. Alright, but we want the equal to cases, so those are the ones we're going to do once we get into the second set. Second thing we're going to talk about in 5.2 when we get to solving systems of linear equations applications of max and mins, which is called linear programming. Alright, the added part of this, so we have the line, and we're always going to do the equal to, so we have every single point on my line, that's the boundary. Alright, every single point on my line makes it true because of the equal to. But then we get to add to it, there's half of the xy plane, right? I've got an xy plane, and I've got some line drawn in it. Right, that would be my ax plus by equals c. And because I've got the equal to, every single point on this line is a solution to my equation. And then depending on whether it's a less than or equal to or greater than or equal to and how that lands, either part of the, so it splits my xy plane in half. You have the area, or the points above it. We'll say instead of area, we'll say the points above the line. Or you have the points below the line. And so it splits it. Half of the answers are above and half of the, so half of the points are above and half of the points are below. The line is my boundary. One of those halves is my answer, and we have to test to see. So one of them, less than or equal to, is above that line, and all the points above that line are part of my solution. Or one of the less than or equal to's, depending on what that c is, right, that constant is below that line. And then so the solution set gets bigger, because not only get the line, but I'm going to get half the points. I'm either going to get the half that's above it, or the half that's below it, just depending on what I'm asked for. And so we're going to look at a simple example. Again, this is something hopefully that you've seen somewhere in your algebra history. Alright, so I want to look at an example where I want to solve it, and we're always going to solve it graphically. Alright, we're not going to solve it algebraically, we're going to solve it graphically. Right, because lines are pretty easy to graph. So solve the inequality 2x minus 3y is greater than or equal to 12. Alright, so the line is equal to, so every point on the line, 2x minus 3y equal to 12 is the solution to, that's the equal to part. And then everything greater than, that'll give me the greater than the 12. Greater than 12 is also a solution. And what that does is it splits it into everything that's on the line is my solution. So all the points x, y on the line (2x plus 3y equals 12), and they're infinitely many, are solutions. And all of the points x, y, which make the 2x plus 3y bigger than 12 are solutions. Which, the bigger than 12, meaning all of the x, so it's either the points above my line or the points below, and that's what I sort of have to figure out. Is it the points above or it's the points below? And sometimes it's obvious and sometimes it's not. You do have to check to see which case it is, which is the obvious case and which is the unobvious case, right, because of how you add and subtract stuff. Alright, so that's what we sort of split it into. So the first thing we do is we find all the points on my line. Alright, so the first thing we do is graph the line that divides my xy plane into an upper half and a lower half, above my line and below my line. Alright, and I usually just use my intercepts to graph, so I'm going to graph, so I'm going to use my 0 for my 2, so this is the first case is when x equals 0, what is y? And this is the case when y equals 0, what is x? Alright, so when x is 0, so I'm going to I'm plugging it into this equation to find my zeros. And so when x equals 0, the 2x is going to 0 out. And so I'm going to be left with, right over here because I'm going to solve it, x is 0, I'm going to be left with negative 3y equals 12 divided by negative 3y equals negative 4. And so one of my points is at 0, negative 4. And then the other one, I plug y in for 0 and I solve for x, so the negative 3y is going to 0 out, and so that's going to leave me with a 2x equals 12, divided by my 2, x equals 6. And so I just always, and I find those points for a reason, because, so remember when we reviewed lines, I reviewed this in chapter 1, those are actually going to come into play in the next section. Right? A lot of times we're going to find what are called corner points in a certain region. And a lot of times our corner points will be intercepts of our lines. Not always, but a lot of times they are. Alright, so graphing it, so 0, negative 4 puts me here. There's my 0, negative 4 point. And then my 6, 0 puts me there. And when I'm usually in class, I have a straight edge, which I wish I had now. And if you look on my, when I complete the notes, I did use the straight edge. But try to draw it as straight as I can. It's a little hard on my tablet. Alright, so there's my line. Every point on that line is a solution to this. If I pick any point on that line, take x and multiply by 2, subtract 3 times the y value, it's equal to 12. And so then I have the upper half, so I've got my upper half, which is the half above, and my lower half, which is the half below. And I want to know, are the points above the line, or the points below the line going to solve the inequality part? So the second part is I want to solve this. What points, either above my line or below my line, when I plug them into 2x minus 3y, my answers will always come out bigger than 12. And so what we do is we'll pick points. So I picked 2 test points here. One above my line and one below my line. So one test point was at 0, 0, so 0, 0 was here above it. So there's my test point 0, 0. And another test point I picked was at 0, 6. So my second test point was over here at 0, 6, which would have been down here. 0, negative 6, or 0, negative 6, and I tested it. And so to test it, you literally plug it into that equation, and so when I plug 0, 0 in, everything's going to 0 out, and then we get the inequality 0 is greater than 12, which that's false. Alright, so I check the other side, which the other side should come out true, but I check it to make sure it does, so I plug in my other point, which is on the other side, 0, 6. Again, I'm plugging it in here, so 0 for x, I keep saying 6, negative 6. Negative 6 for the y, and so we get negative 3 times negative 6, which is 18. 18 is greater than 12, and so that's true. And so the area that's true is where the test point, so this was my true point. This was my false point. And so in algebra, typically what we do, in an algebra class, you shade in the half that represents all the solutions to the inequality. So you shade the side that contained the point that you tested that had the inequality come out true. So that would be the side that contained the point 0, negative 6. This is how you solved it in an algebra class. You can always double check yourself if you're unsure by testing more points. Alright, but this would be every point below this line makes my inequality true. Every point, if I plug in any point below that line, I'm going to get numbers when I take it. The x value times 2, subtract the y value times 3, it should come out greater than 12, not less than 12. Less than 12 would be above it. And so this would be my solutions. Right, everything on here is the solution. Again, that's typically, if you remember from algebra, that's typically what we did in an algebra class. Now, I am going to throw you on kilter here a little bit. In this class, we will be using an alternative method. What we're going to do is I'm going to leave the solution region unshaded. Alright, leave it unshaded. We're going to block out the unwanted regions, the best way to think about it. I'm going to cross out the unwanted parts. And so the part that's not crossed out is my solution. Alright, so again, leave the solution set unshaded. And the reason why is because of what we're going to do in the next section. We're going to have multiple lines and multiple things we're going to shade, more than one line. And so it's a little easier to tell what my solution is if I leave the solution unshaded. It's harder to tell where the shadings cross over each other, which again, in an algebra class, that's typically how you do it. Right, we're going to kind of switch it up here on you. And so the same problem, and so I actually graphed this out on my calculator. You can actually do this on the calculator. Calculator will shade this for you. And so there's my line, so that red part, that's my line, that's my boundary, that's the 2x minus 3y equals 12. This was the solution, was below the line, and so what we did is we blocked out. This is all the false stuff, so this is the false side, and so what we do is we block out the false stuff. Alright, so everything above it's false, we're scratching it out. The open points, if I pick any point over here, it makes it true. So that's where we're going to go a little different than what you might have seen in an algebra class. Alright, so I'm going to stop there. I'm going to pick up my next video, and we're just going to practice this in the next couple of examples. So I'm going to practice one by hand. I'm going to practice a few by hand. And then I will show you how you can do it on the graphic calculator, although I personally feel like the graphic calculator is actually a little slower, but I will do one at the end of these notes using the graphing calculator. Alright, we'll stop there.